What's going on, my guys? So today we're going to be looking at the final part of our paper 1 content, which is data handling. So data in psychology. So what is it? Or why do we need to look at data within psychology? Well, psychologists collect data to understand human behavior, cognition, and emotions. Data can come from experiments, surveys, case studies, or observations, and it is essential to organize and interpret it correctly to draw meaningful conclusions. So let's have a look at quantitative and qualitative data and try and get an understanding of what they both are. So quantitative data. These are numerical data that can be measured and quantified. Examples of this include things like test scores, reaction times, and number of errors that people may commit. So these are things that we can count. Qualitative data, on the other hand, is descriptive data that characterizes but does not measure attributes or phenomena. These are things like interview transcripts, detailing participants' emotions, descriptions of things like body language, open-ended survey responses where people have the option to actually elaborate on the responses that they give. We've also got nominal and ordinal data. Nominal data are categories without a specific order, so for example things like types of therapy, whereas ordinal data are categories with a specific order but unequal intervals. Things like Likert scale ratings, when you say, okay, give 5 is very satisfied, 4 is somewhat satisfied, and so on and so forth. Primary versus secondary data. So primary data is data that is collected firsthand by the researcher for a specific study. Examples of this may be things like conducting an experiment, administering questionnaires, or observing participants in a controlled setting. Secondary data, on the other hand, is pre-existing data that is collected by others but used for new research. And examples may be things like government statistics, so things that you get from like a census, previous psychological studies, and archived interview or case studies. Descriptive statistics: mean, median, mode, and range. Let's have a little look and see what they are exactly. So the mean. So if we've got a list of numbers, so 4, 6, 8, 10, 12, and 14, we're going to add them all together. So 4 plus 6 plus 8 plus 10 plus 12 plus 14, and that equals 54. We're then going to take that number and we're going to divide it by the total number of numbers you just added together. So 54 divided by 6, and that equates to 9. So the mean is 9. So the mean is all of the numbers added together divided by the amount of numbers, and that gives us our mean. So when you are asked for the mean, that's how you work that out. The median. Now the median is when we take a list of numbers, we rearrange those numbers in ascending order, so from smallest to largest, and we select a number that falls in the middle. So with our list of numbers here, we went from 8, 6, 4, 12 to 10. We put them in order from smallest to largest, so 4, 6, 8, 10, and 12. We then selected the number that falls in the middle. So we've got 4, 6, 8, 10, and 12. 8 falls in the middle, so 8 is the median. So just think of it like the number in the middle. But what happens if we've got two numbers in the middle? So for example, 4, 6, 8, 10, 12, 14 has already been put in ascending order. We're going to select the two middle numbers. So in this instance, it's 8 and 10. We're going to add them together, which gives us 18. We're then going to divide this total number by 2. So 18 divided by 2 equals 9. And 9 is our median in this case. So if we've got an even set of numbers, then we have to take those two middle values, add them together, divide them by 2, and that gives us our new median. The mode. Now the mode is the number that occurs most frequently in a set. The word la mode is fashion, so it's the one that is in fashion. So we've got this list of numbers. We've got 3, 3, 6, 7, 8, 3. No 6, 7 business, please. So 3, 3, 6, 7, 8, and 3. So as we can see highlighted here, we've got the number 3 appearing 3 times. So the mode is 3 because that occurs the most frequently. The range. How do we work out the range? So the range is the difference between the highest and lowest values in a set of numbers. So for example, here we have 3, 6, 9, and 12. The highest number is 12. The lowest number is 3. We subtract the lowest from the highest. So 12 subtract 3 equals 9. The range is 9. So our range is 9 from this set of numbers. Visual representations of data. So frequency tables. Frequency tables are a structured way to organize data, showing the number of occurrences of different values. So in this table that we can see on one side, on the left side, we can see that we've got scores, and on the right side we can see the frequency. Now the frequency is the amount of times that it occurs. So let's start off. So the amount of people that scored 1, we had that occur 5 times. So it occurred at a frequency of 5. So it happened 5 times. People scoring 2 was a frequency of 2. So that happened twice. People scoring 3 happened 4 times. So there's a frequency of 4. And people scoring 4 times only happened once. So there's a frequency of 1. So the frequency table shows us how many times a certain thing happened. So the score was 1, happened 5 times, so it happened at a frequency of 5. Bar charts. So these are used for categorical data. Each bar represents a category, and the height shows the frequency. So we're going to look at an example, and this shows the frequency of different psychological disorders such as anxiety, depression, stress, and phobia. So each of those fall within their own category, and each bar represents its own category. So here we see on the left axis, we can see that it's the frequency that it occurs, and on the bottom axis we can see that we've got the different disorders. We've got anxiety, depression, stress, and phobias. And at the top we have our title, and this title gives us our explanation of what the table is actually about. So frequency of psychological disorders. So anxiety. So we can see from this bar chart that anxiety occurs at a rate of 15. Depression occurs at a rate of 25. Stress occurs at a rate of 10. And phobia, frequency of 5. So you can see none of these bars are touching each other, right? And that helps to identify the fact that they are all separate categories of things that are being measured, okay? Histograms. So these are used for continuous data. These bars, unlike the bar chart, these bars touch each other to show a continuous range. It displays the distribution of exam scores across different score ranges, is the example that we're going to be looking at. We've got 2 types of distribution. We've got normal distribution, and when we have something that is a histogram that is normally distributed, we're going to see an example of it, but it looks quite symmetrical and it gives a bell-shaped curve centered around the mean. A non-normal distribution is when it's either left or right skewed, and right skewed distribution is one we're going to see is where most values cluster on the left with a long tail to the right. So let's have a look at that now. So it said the example on the left here shows a normally distributed histogram. So you can see it gives a nice curved shape, looking like a bell curve. So it's not exactly symmetrical, but overall it gives quite a symmetrical feel. And this non-normal distribution, which is right skewed. So as we can see, we've got it starting off quite high and then tapering off into a tail towards the right. And whenever we have the tail on the right, that is why we call it right skewed. And if it were the other way around, if we had the tail on the left, then it would be left skewed. Scatter diagrams and correlation. So scatter diagrams show relationships between 2 variables. We have positive correlation, negative correlation, and no correlation. So positive correlation, both variables increase at the same time. They both increase together, so they both go up. That shows positive correlation. Negative correlation is when one increases while the other decreases. So one variable increases while the other variable decreases. We're going to look at examples of this so it makes it a little easier to understand. And no correlation is when there's no clear pattern established between the two variables. So let's have a look at that. So starting off with on the left here, we've got positive correlation. So we've got test scores, and we can see that those are increasing as we go up the axis, so 40, 50, 60, 70, 80. And then on the bottom axis, we've got hours studied. So if you think about it, the more hours that you spend studying, so when the hours increase, then the likelihood of your test scores increasing also increases, right? So let's have a look at what that looks like. So starting off from the left here, we can see that we've got very few hours studied, so less than 1 hour, test score of 40. But then as that goes up, as we progress along, once we study for 2 hours, then it goes up to about 45 for our test score. And if we go all the way to the end, so we say 10 hours of study, then that goes to around 85 in terms of our score. So the amount of hours that we studied increased. We studied for more hours, and because we studied for more hours, our test scores also increased. So both of those variables went up. So let's look at negative correlation, one that is in the center. So stress levels is our bottom axis, and sleep hours or hours of sleep is our left axis. So this is a negative correlation. So one is going to increase while the other decreases. So if you think about it, if we decrease our hours of sleep, the likelihood is that we're going to feel more stressed. We're going to feel more groggy. We're going to be snapping a lot more. So our stress levels are going to increase as our level of sleep or our hours of sleep decrease. So let's look at what that looks like. So as we can see, it's going down in the opposite direction. So hours of sleep, as that increases, so we've got more than 10 hours of sleep. That's a lot of sleep. So as we can see, our stress is very low. So remember, going towards the right, our stress level increases. So 2, 4, 6, 8, 10 levels of stress. So as we can see, let's start off on the left. We've got good amount of sleep, over 10 hours sleep, and we can see that our level of stress is very low. It's nearly at 0 or nearly at 1. Whereas if we go all the way across and we only had 2 hours of sleep, we can see our stress level is all the way at 10. So it is like the maximum level of stress. So as our hours of sleep increased, our level of stress decreased. So one has increased while the other has decreased. Now on the right here, we can see that we have no correlation. Let's bring that up and see what that looks like. So as you can see, between variable y, which is on our left axis, and variable x, which is on our bottom axis, there is no correlation. The points that have been placed are all over the place, and we can't find any, whether it be positive or negative correlation. So there is no correlation at all. So ensuring reliability and validity, just a couple of things to take note of when thinking about collecting data. So reliability, we've got different types. We have internal and external reliability. Internal reliability is when there is consistency within the test. So things like the split half method. External reliability is when there's consistency across time or situations. Validity, again, we have internal validity, and this is basically representative of whether the study measures what it claims to be studying. And external validity, which is the level of generalizability of the results to other types of settings. Okay, let's move on to computation. And a lot of the times people get quite stressed out about this part of psychology and this part of research methods, but I'm going to try and break it down for you guys so it's as straightforward and easy to follow as possible, and hopefully that kind of increases you guys' confidence when it comes to sitting your exams. So computation, so what is it and why do we need to do it? Well, in psychological research, using decimals, standard form, ratios, fractions, percentages, estimates, means, and significant figures is vital for accurately analyzing and reporting data. These skills help researchers summarize results, compare groups, estimate trends, and present findings clearly and precisely. So that's why we need to do it. Accurate numerical reporting also supports replication, statistical analysis, and effective communication of results. All right, so we've got this question. right? And this is something that this is very similar to a question that you guys might get in your paper 1 exam for your research methods, and actually through paper 2 as well. There are some research methods sections dotted about. So a psychology student is gathering a stratified sample of 250 students for a questionnaire. The full college population is 2,518. Learner, calculate the percentage of each subgroup. So these are the groups that have been broken down within the college. So we've got 1,462 BTEC learners, 602 A-level learners, 258 GCSE learners, 196 access to HE learners. So on the left here, we've got all of our courses. So we can see BTEC, A-level, GCSE, access to HE. We've then got our learners. So our 1,462 BTEC learners, our 602 A-level learners, our 258 GCSE learners, and our 196 access to HE learners. We're going to work out the fraction, the decimal, the percentage, and then the finalized percentage once it's rounded up or rounded down. So we're going to go through these together, so that way we make sure that we understand fully how it's done. All right, so putting this as a fraction, so we're starting off with the BTEC. We'll do it all together, and then we'll work our way through them. So working it out as a fraction, we work this out by placing our 1,462 learners. We're going to divide that by our total number, which is 2,518, which is the student population. That will give us our decimal of 0.580619. So that's our decimal. To work that out as a percentage, we need to times that by 100, or move our decimal point 2 places to the right. And that will give us 58.0619. We're then going to round that up or round it down depending on the following number after the decimal point. And here we have 0. So that is going to be rounded down to 58%. Okay? And that's how we work out each one of those. So let's do it again. So for our A-level learners, we've got 602 A-level learners. So we're going to divide that by our total student population. So 602 divided by 2,518. That will give us our decimal answer. And also, guys, just a quick note, remember, in your GCSE psychology paper, make sure you remember your calculator. So back to it. So that gives us our decimal of 0.239078. We're going to times that by 100, so we're going to move that decimal point 2 places to the right. That's going to give us 23.9078. We've got 9 after the decimal point, so let's round that up to 24%. That's our percentage. Let's go through it again with GCSE. So 258 GCSE learners, we're going to divide that by our total student population, which is 2,518. That's going to give us our decimal of 0.102462. We're going to times that by 100, so we're going to move that decimal point 2 places to the right. We've now got 10.2462. The number following that decimal point is 2, so we're going to round that down to 10%. Nice and easy. All right, guys, I'm going to actually pause the video here, and I want you guys to work out the access to HE for me. Okay, cool. Let's go through it again. Let's check your answers together, because this one might have thrown some of you guys a little off, and let's have a look at it. So 196 divided by 2,518 is our fraction. We're going to get 0.077839. We're going to times that by 100, so we're going to move that decimal point 2 places to the right, which is going to give us 07.7839. We're going to then round that up to a percentage, but how are we going to do that? Well, that's going to be 7.8. And why is that? Well, because following the decimal point, we have 7. The number following that is an 8, which is above 5. So that is going to round us up to 7.8%. Yeah, so that's how we work out our fraction, our decimal, our percentage, and then our final percentage based off of the information that we've got. But make sure that you read through the question that you get properly, take your time with it, and that will assist in our responses. Alright guys, I hope that gives you a good understanding of data handling within psychology. Now I know like I said, I know it's something that's going to trip up some of us and something that we might have a bit of a worry about, but as you can see, it is pretty straightforward. Just keep looking over this video, take in all of the information that you can, and we got this. Alright guys, so make sure if you haven't already that you like, you subscribe. I'll catch you guys in the next one. We're going to be looking at paper 2 content. Peace.